Okay, back to what we were talking about. What's our next step now that we've identified the appropriate half reactions?
Balance.
We have to balance them by mass. Okay? And as I recall, yeah, we've got that over here. So, here is one half reaction. Ooh, maybe. Let's do this. Whoops. No, down here. All right. There's one of our half reactions. Let's balance it. What do we have to do to balance this by mass?
Add hydrogen sulfate.
Yeah, we've got to add sulfuric acid on this side. Okay? Okay? So that balances sulfur, right? We're already balanced with lead. So, well, because that's what we have.
Oh, you can only add what you have. Got it.
You can add what we have. Now remember that what we have usually is going to include H plus and water.
But it's just in something.
Yeah, right. So we can add this. Okay? This is now balanced by mass for lead. It's balanced by mass for sulfate ion. But now we have some pesky hydrogen left over. What do we have to do with that? Where? To the right. Plus 2 H plus. Now what do we need to do? Add 2 electrons where? On the left or the right?
On the left side.
How many vote for the left? How many vote for the right? Explain to me why right is the correct answer. Yeah, this has no net charge on this side. Lead is neutral, H2SO4 is neutral. This has a +2. To make this a 0 charge, we're going to have to add 2 electrons. Now this has a total charge of 0. Okay? This is balanced by mass, this is balanced by charge. This half reaction is taken care of. Now, let's go back and select that one. All right. There's our other half reaction. What are we going to have to do with this one?
Add H2SO.
Okay, we're balanced by mass for lead, right? We need to have some sulfate ion, don't we? Over here, right? So plus H2SO4. That's now balanced by sulfate. Now what do we have to do?
Add water on the left side.
Okay. Let's add water to balance this excess oxygen. So that's 2, right? So where are we going to put the water? Right side, and we need 2 of them, right? Okay? Now, we need to balance hydrogen. How many hydrogen do we have over here?
4. We need 2 on the left side.
You're going to need 2 hydrogens on the other side.
Wrong class.
Okay? Anything else? Two electrons where?
That would be right.
I'm going to say on the left. Everything over here is neutral. We have a positive charge on this side. We have to offset that with negative electrons. Okay? Yeah, it does make sense. If we have electrons on the right on one reaction, we have to have them on the left on the other, don't we? If we don't have that, we're never going to get these things to mix. Okay, now we add them together. So what can we cancel? The very first thing we should look at canceling is the electrons. 2 there, 2 there, we're good. Can we cancel anything else? Oh yeah, we got 2 hydrogens there and 2 hydrogens there. Let's get rid of those. Anything else? Well, both PbSO4s are on the same side, so we don't want to cancel those. Everything else we can just add, right? So on this side we have a lead. And we have, what's this called? Close. What was the oxidation state of lead in here? Lead 4 oxide. That's also solid. What else do we have? We have 2 H2SO4. Okay? What do we have on the right side? 2 lead 2 sulfates. And 2 waters. Now, I hope that this doesn't freak you out very much, but if you look at this real carefully, you notice you have the same element being oxidized and reduced. That happens sometimes. If you have things that have multiple different oxidation states, you can see that. Oxidized and reduced. Okay?
Wait, can I see the end of that?
Oh, sorry. 2 waters. Ah, we kind of forgot our 5th step. Should we do that real quick? Let's confirm that it's balanced by mass and charge. First of all, is this balanced by charge? There are no outstanding charges. Everything here is neutral. So that's good. Okay? So let's see. We have 1 lead, 2 lead, 2 lead there. We have 1, 2 oxygen, 3, 4, 5, 6, 7, 8, 9, 10 oxygen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygens. We have 2 sulfurs and 2 sulfurs. We have 4 hydrogens, 4 hydrogens. We're set. Okay? That's basically how you do oxidation reduction. Okay? Now, as I said, oxidation reduction reactions usually will take place in either an acidic or basic solution. All we've talked about so far is the acidic case. We'll worry about basic next time. Okay? But I think this is probably enough new information to give you in one day. Let me dig through the book and figure out which problem or problems you can now do based on this. Next time we're together, I think we can finish up Chapter 4.
Okay, I was